Hello Candles, welcome to Candela Learnings. My name is Albert Bonnie and today we continue to learn about our eye. The topic of discussion today is power of accommodation, the magic that happens in our eye. To begin with, let's start with a simple experiment. I would like you to keep your index finger in front of your eye and focus only on the index finger for the next 2 seconds. Too simple, right? You are able to see an index finger. What is so magical about this? But now let's make it a little bit more interesting. Keep your index finger, but instead of focusing on the finger, look at an object that is very far away. For me, I have a pillar there that I'm going to focus on for 2 seconds. Something magical happened here. Your eye chose to focus on an object that is very far away even when you had an index finger right in front of you. Now let's think about this for a second. Instead of your eye, if it was a camera, you probably would have to focus on the finger, and when you had to look at something that is very far away, you probably will have to focus again. Your eye did all of that automatically. How does this happen? And this is what we are trying to deep dive in today's topic. But before actually stepping into this chapter, I'm going to do a quick revision which will give you some clues on what we will talk about today. You will be able to see a thick lens. A thick lens means a lens which has higher curvature and the focus of that lens very near to the lens. Now when this lens becomes thinner, your focus moves far away from the lens. Now let's do it again. When this thin lens becomes thicker, your focus moves closer. But what is the significance of this? Why do we discuss this here? Something that you already learned in the last chapter. Let's see. If it is a thin lens, then the focal length increases. And here comes the most important point. Images of distant objects are formed easily. And when your lens is thicker, the focal length decreases and images of nearby objects are formed very easily. Armed with this knowledge, we are ready to deep dive into our topics. There are mainly three topics of discussion for us today: power of accommodation, near point of eye, and far point of eye. We'll first focus on power of accommodation. Now, I'm not going to tell you what is the definition of power of accommodation is. Instead, I'm going to give you two questions which you will answer with the clues that I discussed, and then we will together figure out what power of accommodation is. Are you guys ready? Okay, here is the first question. How do we see nearby objects? To see a nearby object, your lens should be thicker. Now, for a human eye lens to be thicker, your ciliary muscles should contract and your lens become thicker. When that happens, your focal length decreases and now you are able to see nearby objects. Here comes the second question. How do we see distant objects? I'm sure you're figuring out what the answer is. To see distant object, your lens need to be thinner, and for this, your ciliary muscles should relax. And once that happens, the focal length increases and you are able to see distant objects more clearly. With this knowledge, let's try to decode what power of accommodation is. Power of accommodation is the ability of our eye to adjust its focal length depending on the object that is in front of it. This is something the eye does by itself depending on where your object is. Now let's move on to the next topic. It is near point of the eye. Near point of the eye is the minimum distance at which an object should be kept for your eye to form its image without straining itself. Now this is an important point, without straining itself, because I could always keep an object very close to my eye and strain on it. But this is the problem. My eye has to go through some strain. Near point is where there is zero strain involved. For a human adult like you and me, it is 25 centimeter. I'm sure you're thinking, but sir, I am able to see an object that is at 20 centimeter. My friend is able to see something at 15 centimeter. And you are right if you're thinking this. Because this 25 centimeter is the average of all the people in this world. So on an individual basis, it would change. But as an average, we arrive at 25 centimeter. Now let's move on to the next topic. It is far point of the eye. It is the exact opposite of near point of the eye. It is the farthest distance at which an object need to be kept for the eye to form its image. Now, for a human adult, it is infinity. I'm sure it is a little difficult to believe. Here is what I would like you to do. Step out today evening from your home and just look up. Are you able to see the stars? Because if you are able to see the stars, these are stars which are billions and billions of kilometers away, but still able to form image in your eye. So if that is visible, then we have to believe that our eye is able to see objects at infinite distance. So let's quickly rewind what are the three topics that we learned today. Power of accommodation, the ability of eye to change its focal length, near point of the eye and far point of the eye. Let's do one visual representation of these two topics to fully immersify in this topic. Here you will be able to see a eye lens which is thicker and the near point of the eye is also marked. Now when the eye lens becomes thinner, your near points move back and becomes the far point of the eye. Let's do it one more time. When the far point comes closer, your eye lens will change from thinner to thicker. This visualization will help us connect all the topics that we learn in today's session. I hope we were able to decode the magic that happens in our eye. Tune in more for the next session to understand what are the defects that are happening in our eye which affect this magic. Till then, see you and bye bye.